So welcome everyone to this open webinar of the Trustworthy Consortium. So today we have the pleasure to introduce two good friends and partners in the Trustworthy Consortium from the Joseph Institute in Ljubljana, is Dragi Kocev and Panche Panov. They will talk about trustworthy resources for data harmonization and analysis of stroke data. So Dragi and Panov, Panche, welcome, and thank you very much for joining today to us in this webinar. Please go ahead.
Thank you, Carlos, for the nice introduction. So I hope you all see my slides.
Yep.
So I'm Dragi Kocev, and together with my colleague Panche Panov, we come from the Josef Stefan Institute in Ljubljana, Slovenia. We primarily work in the field of trustworthy AI and ensuring trustworthiness in the developed resources. And in this presentation, we will have two topics. So the first one is trustworthy AI. What are the main concepts? What is the trust stroke view on trustworthy AI? And I'll show an example of how such a repository of trustworthy AI resources can be developed. And in the second part, Panche will talk about data harmonization among different entities and different sites. So in terms of trustworthy AI, I will touch upon three major items. The first one being the recent AI Act by EU. It made headlines in the past couple of days, and it's expected to come into effect fairly soon. So what does it mean essentially, and how does it affect the execution of the TrustStroke project? The second part is the trustworthy AI guidelines that are being developed and proposed by various international entities and bodies, how this can be translated for brain stroke data analysis, and how this can be implemented within our TrustStroke project. And finally, I'll show an example of a repository of trustworthy AI resources for brain stroke data that we have developed here at JSI. So this is just a small prototype pilot repository to illustrate the main concepts that I will present. So let's start with the EU's Artificial Intelligence Act. So it's the world's first comprehensive AI law, and essentially it tries to address risks, to identify the risks of using AI. And then mainly these risks are focused around the fundamental human rights and the violation of those that might arise by using AI. So essentially it will, the scope of application will be to both entities that provide AI systems, as well as entities that deploy at their sites AI systems. And essentially it will focus on all the AI systems that somehow are used by EU citizens, regardless of where they are established and where they are deployed. There are several exemptions. The exemptions of this strict application of the AI law will be for research and innovation, for defense, and for non-commercial, so private use. Most likely, the changes will come into effect 2026. This still coincides with the timeline of the execution of TrustStroke, and down the road, we will need to show compliance. The key points of this law are identification of risks, regulation, and boosting excellence in AI. Briefly, I'll mention these three notions. There are several types of risks of the using of the AI systems that have been identified. The first one and the most stringent one being unacceptable risks. That means that AI systems that fall within this category will not be allowed under any circumstances. And these are examples of these are social scoring of citizens, real-time biometric identification in public spaces, so tracking of people, emotion recognition of workplace, and so forth. So these are excluded and are not allowed. Then there are these high-risk systems, and here there are two main groups. The first one being the first group belongs to the EU's product safety legislation, and here we are dealing with products such as toys, aviation, cars, medical devices, elevators, lifts. In this sense, in the respect of TrustStroke, we are I highlighted these medical devices. That means all the medical devices that use AI will be marked as high risk, and they will need to follow the protocol for such systems. The second part is AI systems that are focused on biometric analysis, managing the critical infrastructure for education, management of workloads, rule of law, migration. If some of these areas are touched by the AI system, then it will be marked as high risk, and it will be subjected to the regulation rules set out in the AI Act. Also, there is this specific transparency risk group of AI systems. There is, for instance, these are AI systems where there is clear risk of manipulation. So as an example, it's here the use of chatbots. However, in this type of AI systems, the user should be informed that they are interacting with a machine, and to have more information, more transparent information about how this machine was built, on what data, what methods, and so forth. And then there are these minimal risk systems. So this is most of the AI systems that will be developed and used throughout EU. Here there is no specific regulation foreseen. However, it's recommended that also this system adhere to the principles and guidelines of trustworthy AI. So in terms of regulation, so there will be EU-based EU database of high-risk AI systems where different steps will need to be completed in order to register the system into that database, and that database will take care of the compliance of the system to the AI Act. So I will not go into details about how these steps will be effectively technically enforced. I will just briefly also mention how it is planned to be enforced. So different bodies will be formed. The most prominent one being European AI Board, which will be a very high level, will be composed of high level representatives of member countries. And they will essentially oversee the implementation of the AI regulation. The European Commission will open also European AI Office that will have support from scientists in order to make this process run as smooth as possible. Essentially, what will happen here is that all these systems, AI systems that are used throughout EU, will need to undergo some registration process and monitoring process throughout their whole life cycle. And how this affects the execution of TrustStroke. So luckily, we were very aware of this even in the project proposal stage. TrustStroke platform will be developed with having in mind the trustworthy by design principles. So we are taking care of these trustworthy issues a priori. We will be compliant to the recommendations for trustworthy AI. The most strict implication would be on the part of the project that stipulates the development of roadmap to certification, because now the certification of medical devices that use AI will have a special checkup and registration in these registers. So whenever we will prepare this roadmap to certification, we will need to take into account these aspects. Now, once we cover the EU's AI Act, I would like to briefly talk about trustworthy AI. And I'll start by what does trust mean in this context. And I find the definition about from this sociologist Niklas Luhmann very nice and very correct. So the trust is an attitude that allows for risk-taking behavior, and the function of trust is the reduction of complexity. Essentially, the AI systems that we developed are very complex and they have very intricate design. The trust in them is to reduce this complexity to simple terms that are manageable to a wider population. And when we talk about trust, trust is a multi-layer concept, and it has been defined as such in this International Telecommunications Union recommendation that they have issued. And this concept of trust is in 3 layers. The first one deals with the physical trust. So we need to be sure that the components that we use, for instance, the infrastructure for data collection, the sensors, the actuators, they need to be accurate and trustworthy. So we know that the readouts, the measurements that we see are indeed these numbers. The second layer of trust is the cyber trust that deals with the integrity and security of the infrastructure that supports the AI systems in terms of security, integrity of the data, security, integrity of the models, AI models. And the third concept is the social trust, and this is how the AI systems are being perceived by individuals. This part of the trust, this layer of the trust is influenced by a variety of factors, such as how we perceive the system's behavior, how transparent that system is, how biased this system we perceive it, and so forth. And all these 3 layers need to be supported by robust AI systems in order to secure this ecosystem. Now, in terms of guidelines for ensuring trustworthy AI, I'm listing the 7 guidelines that were developed by the high-level expert group composed of experts invited by the European Commission. I would like to note that all the major international bodies like OECD, UN, CHI have more or less developed their own guidelines, but most of them are conformant and focus on similar issues as the ones that I'm listing here. Without going into much details, I'll just enumerate these. So the first one is ensuring that the AI systems are augmenting the human capabilities, and the human remains in the control of the operations of that system, so human agency and oversight. The second one is technical robustness and safety, and this pertains to the multi-layered perceptions of trust that I mentioned earlier. The third one is privacy and data governance. So we need to ensure that the integrity of the data is intact. Then transparency. And here, the 2 main concepts are that the decisions that are made by AI systems need to be explainable and traceable. That means that I need to know what data were used, what systems were used, what methods were used to learn the models, and properties of the data, whether the biases were taken into account, and so forth. The next part is it needs to account for diversity, non-discrimination, and fairness. And this relates to considering different biases and bias mitigation measures. The sixth one is environmental and societal well-being. So the AI systems should have positive impact on the society and the environment. And the final one is accountability. The AI system should provide means about for accountability of the actions and the decisions that have been made using them. Now, one of the central concepts that build upon this trustworthy AI aspects is the FAIR principles. And these FAIR principles pertain typically to data and to data-like resources. FAIR here stands for findable, accessible, interoperable, and reusable. Essentially, FAIR enhances the usability and long-term value of research data, and it's focused on data stewardship across the complete data life cycle. Using these FAIR principles, we are able to address issues of data fragmentation, which is very often in healthcare systems, dealing with issues of lack of transparency and difficulties in finding and using data. How these FAIR resources translate for brain stroke data and how they are relevant for us in this specific case is that through compliance to the FAIR resources, we need to ensure data integration and aggregation. So stroke research typically relies on different data sources, different types of data, different clinical data, imaging, genomics, patient records, and all of this needs to be put together and used and exploited. Then accessibility of patient data. So this is crucial for timely and accurate stroke diagnosis and treatment. So we need to have healthcare professionals patient relevant data as soon as possible. Merging together genomic and biomarker data, especially for strokes that have genetic component, and identification of genomic markers associated with stroke data can aid prevention and treatment of such cases. Personalization, that means if we are able to create databases to include different patient profiles, we will be able to facilitate personalized treatment decisions. Then it will enhance collaboration, because it provides the framework for different actors, different players to come together and work together to create this single viewpoint on the problem. And FAIR is especially critical for big data and AI. That means if the data resources and the other resources are fair, deployment and using AI will be much simpler and much easier. Next is data security and privacy. And here, this is one of the crucial aspects of FAIR, that FAIR data practices can include robust security and privacy measures. These measures essentially protect the patient data and control access to the data based on the necessity. So it can specify what type of personnel has access to what type of data. And last but not least is the ethical considerations, because the FAIR principles for handling brain stroke data can include ethical principles to ensure the ethical principles, including informed consent, data and data anonymization. What I would like to stress here is FAIR resources is not equal to open resources. When someone says that the data are fair, that does not mean that the data are open. Open data pertains to having the data publicly available, open for everyone. FAIR has a layer of semantics that provides for data stewardship. So the data can be fair, but they don't need to be open. What needs to be findable is the metadata part. In terms of verification of brain stroke data, I'm just showing this, the only example about that I was able to find about making brain stroke data fair. And this deals with MRIs from 2,888 patients with acute stroke event, and they were just made publicly available as a pair data resource only recently. So in August 2023, I was able to find that they have almost 450 downloads thus far, which is an excellent number. The images here show on the left-hand side, we see the language for describing the metadata and how these images were compiled together. On the right-hand side, I'm showing the much needed understanding aspect where the different types of data are somehow summarized into this into the graphs that are shown that provide a glimpse into the whole repository. This data is fair and it is open for download. So the images are available for download. The next concept that is really important for ensuring trustworthiness in the AI system is the biases and how these affect the analysis, the downstream analysis. In terms of stroke data, I'm showing here several types of biases that can be encountered in the data that we have, and these are population bias. So essentially, this deals with the fact that we are typically looking at subjects from specific demographic groups or demographic regions. Then socioeconomic bias, and this is again dealing with the different subjects that we're looking at and their different socioeconomic background. That means that they have different habits, different lifestyles, and then this introduces some kind of bias into the data. Then we have the healthcare system bias. This essentially captures the differences of the level of healthcare infrastructure that is available in the different regions. In terms of the regions with more advanced healthcare infrastructure will have more systematic data collection and more accurate data collection. The regions with limited levels or limited resources for healthcare infrastructure will have incomplete view on this problem, and it will make it difficult to understand the stroke patterns and outcomes. Then it's the racial and ethnic bias, so this is fairly clear. The gender bias, so this is also fairly clear because that men and women are affected by stroke differently, and this needs to be taken into account. Then we have the temporal bias, and here we have this from two viewpoints. The first viewpoint is that the historical viewpoint. So if you try to merge data from 10 or 15 years ago with data that is collected now, the advancement in technology and the precision in measurements alone will generate some kind of bias into the data. And also the temporal bias is the thing that we've discussed in the previous webinars, is you don't always have perfectly aligned patients that the data were taken at the same time points after the event, and there is no way to somehow compensate for that. Then is the data collection bias. So this stems from the different imaging, different diagnostic criteria that can introduce bias into the data. And finally is the selection bias. So this is when we design the study, essentially how the subjects are selected. And this is affected if some groups or some patient groups are systematically excluded. For example, if elderly patients or those with pre-existing conditions are excluded, then the generalization potential of the models will be very limited. Now, based on all of these, what would be our trustworthy guidelines within the TrustStroke project? So I will not explain these into details, but if you're interested, I can talk for each one of these. Essentially, we need to take care about patient safety and care quality. Then ensuring data privacy and security. We need to be transparent as much as possible, and then ensure robustness and accountability of the models that we will develop. Take care of biases. So first we need to identify the biases that we might have in the data, and then take appropriate course correction measures or mitigation measures to alleviate the potential impact. Then we need to perform clinical validation. So to take all the developed methods, the developed finding, and try it in clinical practice to see how good we did. Then interoperability. So we need to ensure interoperability in terms of interoperability between the different types of users that will use the platform, different types of sources, different types of experts that will work on developing the platform. So all of this needs to work seamlessly. Then we need to take into account compliance to regulatory and ethical issues. And at the beginning of this talk, I already mentioned this regulatory aspect. So we need to take care of that also within the project. And then patient empowerment. So we need to take care that the patients, you need to educate the patients about the role of AI in the healthcare, and essentially that the role of AI is to empower them to take more active approach in the treatment of their condition, so in the treatment of their stroke. And then it's continuous improvement. So AI and this healthcare, it's an evolving field. So we need to take to make to consider that these improvements are continuous, and these should be included into development life cycles and refreshing of the developed resources. So essentially, now I talked theoretically how these things need to be resolved. We, together with our colleagues here at JSI, we've developed a small prototype example of how this repository of brain stroke data should look like. We compiled publicly available data sets, and here we focused on three aspects of this trustworthy AI. First is transparency. We looked at provenance information for the data, the methods and the models, then the robustness of the models, and then trying to explain and understanding the data. Briefly, I'll just show this example, this system. So I hope you see my slides. On the left, this small repository. On the left are listed publicly available data sets that we were able to find for brain stroke. And I'm showing this one because we executed experiments mostly for this one. In this first panel, we are showing provenance information about the data set in terms of what were the variables, what this data set represents, what type of the data, so in which format the data is made available, where this data was found and who created that data, and essentially where this data, the data owner, who the data owner is. In this case, is the UK's Open Data Portal. And what is the available license? In terms of AI models, here we are listing each of the models that we tried on this data set, and we provide direct information and direct link to the specific implementation of that model. So for instance, if I click on any of these, it will show me that for learning here, for learning the predictive models, we used this specific implementation of the ADA boosting regressor. So the implementation of ADA boosting that is available within the sklearn toolbox. So with this, we ensure transparency in terms of data and models. We say, these are the data that we have. This is the data where they are. And these are the AI methods that we will use. And these are their specific implementations. Then in terms of robustness, we executed some benchmarking studies. So here we are showing results from tenfold cross-validation for using different methods. And I'm just illustrating this. So based on this, we can see how stable and how good our performance estimates are. And then I can add here, I can add different methods. So random forests, I can add tagging, and all of this other XGBoost regression. And you see, I can see how the performance estimates change and how they are stable across the data set. This means that the predictions that we are getting using this data are not random, because you see all the performance estimates somehow converge more or less on the same at the same values. Of course, we can also see other evaluation measures. So this is R squared, and here we can see that this is some weird behavior from some of the predictions, which needs to be further investigated. The third part is understanding the data, and here for each of the variables we provide histograms of values and how this data is distributed, so we can see whether there are some outliers, some glitches that we need to address. Essentially, when such a repository is completed, we'll have more experiments executed to showcase to assess the performance. Different evaluation strategies also tested in order to be sure that the performances that we are reporting are the ones that are trustworthy, essentially, that they are robust no matter the evaluation measures. And I will end with these take-home messages. So essentially, the EU's AI Act is about identifying the risks and defining regulatory framework for assessing compliance of the AI systems to human fundamental rights. That means that essentially that the human fundamental rights are not breached through the use of AI systems. The key concept in the AI Act is the trustworthy AI, and this is seen as the key principle to ensure proper use and exploitation of AI systems. And here, again, trust is understood as a multi-layer concept. Fair resources provide this multifaceted view on the data that are much needed to learn good AI systems with good generalization power. Biases and their identification is crucial for the success. So we need to take care of the different types of biases that can be encountered in the brainstroke data. And again, the Truststroke guidelines for developing the platform will rely on the trustworthy AI principles, and these are will be mainly focused on fairness, transparency, robustness, and mitigation of biases. And with that, I hand over to Panche.
Hello.
Sorry, we have a question. Maybe you want to answer it now or later? What do you prefer?
Where can you find fair schemas? Should they do it?
We have a question in the chat for you. Is where can we find resources to create fair schemes for data? Should database structure be changed? How entities can adopt fair principles in practice?
Panche, will you take this one, or should I?
I can try. Yes. So creating fair resources, it's not a simple process, because you have lots of principles that you need to take into account. So the usual procedure is that you need to check the current status of your data. So see what are your weak points and what are your good points. So which FAIR principles you are already addressing with your data and your database and your platform and whatever system that you have set up. And then after you do this first assessment of fairness, that you will find on which parts of the FAIR you need to be more focused on. And what exists currently are recipes for certain FAIR principles, how to tackle them. So what I would suggest that one does is first do a FAIR assessment. So there are several these tools that allow you to assess how fair is your data, and then for the scores that are low, for those principles, check the FAIR recipes and try to adapt some of your parts of your system in order to be more fair. So this would just be for short. We can also have a bigger debate if necessary.
Thank you.
Okay.
So please go ahead and share your screen.
Yeah.
For
Sure.
the second part of the talk.
Mm-hmm. Okay. I hope the slides are visible. So the second part of this talk will be dealing with data harmonization and the importance of data harmonization for brainstroke data analysis. So the first question that arises always is, what is data harmonization and why it is important? So in order to answer this question, we can ask ourselves another question, and that is how we can enable integration and analysis of heterogeneous clinical data obtained from multiple sources. So one way of enabling integration and analysis of data from heterogeneous sources is by doing data harmonization. So data harmonization is a very emerging field which is responsible for development of best practices that leads to homogenization of data that have by nature structural heterogeneities. So as a fundamental basis of data harmonization, we first have data sharing. So in order to harmonize the data, first you need data providers to agree to share their data in order for them to be harmonized and then in a way integrated. So with data sharing, we are in fact, if we are talking about hospital data or clinical data in general, we are linking data from various cohorts and also data from various clinical centers. And the most important thing is that the data sharing part needs to happen before data harmonization. So we need to know the data that we are dealing with before starting the process of data harmonization. So within data harmonization, so this heterogeneity is kind of regarded as one of the limiting factors for effective application of AI methods for data analysis, because if we have heterogeneous data and we want to, and we have different cohorts, different biobanks, then if we want to apply AI methods on top of this schema, we might not get very good results. This is why data harmonization emerged in computer science with the aim to overcome these structural heterogeneities present in this medical data that by origin come from different sources or multiple sources. So the idea is to produce a kind of homogenized versions of the heterogeneous data that are shared within some common medical context. For example, in our case, it is the stroke data. So one thing also to note here is when talking about retrospective and prospective data, with respect to data harmonization, harmonizing retrospective data is a much more challenging task than the task of harmonizing prospective data. Because for prospective data, you can design protocols and agree that the data will be collected according to the pre-selected protocols. And if you are talking about retrospective data, so this is historical data that have been collected by each institution separately without aligning the protocol. So some protocols might align because they are standard, more standard, and other protocols, each clinical site can have their own rules. So this is why we get such a mixture of different things at different sites. So regarding how we tackle data harmonization, there are two conceptual approaches that exist for data harmonization. One is a more stringent strategy, and the second one is a flexible strategy. So in the stringent strategy, the harmonization is limited only on data that will be or have been collected under common procedures. So this is, if you would do a very strict data harmonization, then we would only harmonize the data that are collected under common procedures. This would restrict us too much. And in the real world use cases, I think this scenario will not be very much usable. So this is why there is another strategy, which is called a flexible strategy, which in fact extends the harmonization of data that have already been collected under different measurement procedures or protocols. And this is the type of harmonization that we will also have in the Trustworthy project. So why it is necessary to harmonize data? The first thing that comes to our mind is for data integration. So integration of clinical data from different cohorts and other related resources, but we have the overall context of a specific clinical domain. For example, describing a common disease of interest, such as stroke in our case. Another reason why we would need to harmonize data is if we would like to identify prominent clinical factors which contribute to the prediction of one or more disease outcomes. And they are also, in fact, the outputs of the AI models that have been learned on top of the data. Another reason for harmonizing data is when we want to link distributed data. So what is distributed data? So the data that is stored on different also physical locations and on different clinical sites, and having this harmonized distributed data, it will allow us also to have distributed AI environments and, for in our example, a federated learning platform in order to learn on top of this distributed data. So what are the barriers towards their data harmonization? So where we have problems? So usually there is a lack of standard or common reference model to which you can map to. So majority of these methods for data harmonization, they require a standard reference model to map all the variables or all the terms or field names from the database originating from different sources to this standard reference model. So for all purposes of data harmonization, this model is not always available. So for each domain, one would expect that you will have a reference model, but that model doesn't exist. So what it's usually done is that when we are tackling the task of data harmonization, we are kind of building a common data model out of the models that are the base of each data source. So we are kind of trying to build this standard model and then map the variables or the field names to this common data model in this case. Another barrier is the lack of terminology descriptors for attributes and variables. So what we have in our databases, we have field names, and then in different countries, these field names are usually in the local language. There is lots of use of short names. There is lots of use of undocumented abbreviations, and also use of local colloquial names. So namings of things that are used in a smaller group of people. There is also a lack of data dictionaries on the source side, where one would expect that you would have the field name and then a definition of what this field should contain. Another barrier for data harmonization is also resource and time constraints. So data harmonization can be a time-consuming process, and it requires really a lot of human and computational resources. And what one needs to do when you tackle this problem is you need to balance these constraints. So you need to find the right optimum between spending time and spending resources in order to come to a very reasonable solution. So this part can be sometimes tricky. Another barrier is also lack of descriptors of range values for variables and units of measurements. So you can have coding of variables with different data types and different ranges at different sites. So the same variables, but at different sites, they have different ranges. For example, here I have an example of a variable that has two states, normal and abnormal, at one site, and another site has the same variable, but it records it a bit differently with 0 and 1. So if you want to then use these two variables from these two sources in a same system, then you need to map to a unique meaning of these values. Another problem might arise when you have variables that have ordering in the value space. What an ordering means that the first value is less than the second value and it's less than the third value. For example, at site 1, we might encode low, normal, or high. At site 2, the same variable can be encoded with 1, 2, and 3. and site 3 might have just low and high and not have normal. So you see here, if you want to use this variable, then you need to somehow find the common language of expressing these values. Another problem might arise when you have lab measurements, or you have some devices that produce some results, and these results are expressed in some dimensions. What you would need to do is to establish what is the dimensionality or the unit of measurement for your common variable, and then map it together. Here on the slide we have a few examples of it. So how do we solve some of these barriers, or how we solve some of these problems, is by involving clinicians in the terminology mapping process and ask them to validate our results. This is one thing. Another thing, what needs to be done is to perform data curation on the data source side to fix potential problems with these problematic fields. So identify outliers in the data, incompatibilities, error symbols, notations, and so on, before you start with data harmonization. So typical problems when doing data harmonization. So what could also be an issue is complexity in integrating diverse data sources. So if you have diverse data sources, when they include different data types, structured, unstructured, semi-structured, it can be technically complex and resource intensive if you would like to very closely integrate these data sources. Some people solve this by not doing very tight integration, but do a mapping that would allow the system at the back end to work properly. Another problem that also happens during data harmonization is when you get inconsistent data formats. So one source can use one data format, another source can use another data format. For example, usually when you deal with dates, you need to check a lot. In what format is the date? Do you have the day at the beginning, or you have the month at the beginning? And also the time zones can be also problematic if you have some critical parameters that you need to derive from those dates. So converting those into a single consistent format can be also challenging and time consuming. So you can also have varying data quality at different sites. So there are issues like missing values, which we will have, and we will need to deal with them. We will also have outliers because some measurements come from devices, and devices also, if used at certain conditions, can give you unvalid results. And if these results are stored in the database, they will appear in your column, and you will need to first detect that it is an outlier and then deal with it. So varying data quality is an issue that is always present when you start working with data harmonization. Another thing which is also important are the semantic differences between the variables at different sites. So you can have the same term, so the same variable name at different sites, but the meaning of the concept behind that variable might be different at each site. They call it the same, but the meaning is different. So there is a challenge on aligning these semantic differences when you are building the conceptual model, and it is very important to do this properly in order to have a good definition of your common data model. So another thing that also happens is you can oversimplify your domain. So you can have the risk that you don't use most of your variables because they are not perfect, so that they have missing values, that they have outliers, and you decide not to deal with that part. You just say, okay, they are too complex, too much errors, we just delete them from our study, and you are left off with only several variables which might not have the necessary information for the AI models to use them in the predictions afterwards. So regarding that, learning AI models from unharmonized data, so the potential problems are, as I already said, poor model performance. You can introduce biases and inaccuracies if you don't have everything harmonized. And this also leads to reduced trust in model outputs, and trust is important. So we need to work on the data harmonization in not to lose this trust part. Another thing is overfitting to specific data characteristics. So models tend to overfit to the details in certain data sets. So if you have outliers and you didn't remove them, if you have missing labels and you didn't use the right methods to input values or mark that it is a missing value, you can have all sorts of problems related to overfitting. Then the complexity in the data processing, the inefficient training process, difficulty in model convergence. These are only just few problems that might happen if your data is not very well harmonized. So how do we reach harmonization of the data? We need to follow several important steps. So these are kind of just my view of how one can tackle the harmonization. So first you need to identify the data sources and their data models. Then you need to assess the data quality from different sources like missing values, inconsistencies, duplicate records, and outliers, just to see what is your current state of the art. After that, you will start dealing with standardization of your data by focusing on the data formats, by focusing on the units of measurement, and doing different transformations in order to harmonize this part. In addition, one needs to perform analysis and decomposition of variables from different sources in order to see if your variables are in fact joinable or comparable between each other, and if they mean the same thing. So this is the task 5, semantic variable alignment, which in fact tries to see if the variables in the different centers or the different clinical units have the same semantic meaning. After you do this variable alignment, it will allow you to get a common data model, to construct a common data model, to which then you will map all your source data, and then when you are using AI methods, they will use the common data model language. So here I just wanted to briefly show you this part regarding the analysis and the composition of variables, as this is one of the trickiest, I think, parts of data harmonization. And recently, I've come across this I-adopt framework, which has been specifically designed to address these challenges in representing semantic descriptions of variables by decomposing them into simpler parts in order for one to see if certain variable is semantically the same as another variable. So here the idea is to decompose the variable on several layers and then define the complete context of a variable. So the most important parts here are the variable, the property that the variable explicates, the context in which the variable is seen, the matrix if it exists, and also the object of interest. And of course, with this, we have all sorts of constraints that can arise. Here, just few examples of few variables that I found in the list of our variables from the project. For example, blood glucose is one of the typical thing that is always present in the lab measurements. And what property, in fact, we are measuring with this variable? We are measuring the concentration of glucose in the blood. And what you would have in your database would just say blood glucose. So our object of interest in this case is patient's blood. So, and the context object in which we are measuring these values is it might be the patient dietary intake. It can be some medication that the patient got, and then we need to check if it had an effect or not. The physical activity level or the presence of any conditions like diabetes. The matrix in this case is the patient's body because the blood is located within patient's body. And there are also some constraints related to this variable. So a method of measurement. So is it a finger prick test or it was a venous blood draw? Also, the timing of the measurement is important. So is it early in the morning and the patient didn't have any food, or it is in a random part of the day. Also, maybe the device could be important, the technology used for the measurement, and so on. Another variable is the clinical severity. It's this NIHSS score. So the property that we are in fact measuring here is the severity of stroke-related impairment. And our object of interest is the patient's neurological function. The context object could be the patient's medical history. So if he has some history of previous events. The matrix is the clinical setting in which we are doing this assessment, and the constraint can be different protocols that might be used for the assessment. Also the time frame within which this assessment was performed, and so on. So you can define these things in a very structured manner. One more variable, neuroimaging findings, signs of parenchymal damage. So the property here is the extent and nature of parenchymal damage. So an object of interest here is the brain tissue, and the context objects are the patient's medical history. So if he or she has history of stroke, traumatic brain injury, neurodegenerative diseases, age might be also a factor and symptoms. The matrix is the neuroimaging modality used. It can be an MRI image, or it can be computer tomography. And also there are constraints on this. So the resolution parameters, interpretive skills of the radiologist, and so on. So you need to be very specific when you are trying to define the context of your variable. Just to conclude, I wanted just to show you a few examples of how we start tackling these things, and we will have, I think, lots of fun with with this within our project. And just to conclude, so there is an importance of standardizing data collections and reporting if you want to perform proper data analysis. And for this purpose, a robust data governance practices would ensure that we have good quality of the data and that we have reliable data sources. And there is a need for interdisciplinary collaboration. So this means collaboration between technologists and data scientists as myself, and also healthcare professionals from the different clinical sites. Ethical considerations, we don't need to discuss this too much. It's very obvious that it needs to be handled because we have patient data, and these things should be handled carefully. So when doing all of this work, one always needs to keep patient outcomes at the forefront of these data harmonization efforts. And having this harmonized data, it can lead to better research outcomes if we manage to perform this part good. It will then reflect also when we are using AI on top of all of this harmonized data. So this would be all from me. Thank you. And if anybody has any questions, I'm at your disposal.
Thank you very much, Panchev and Draghi, for this comprehensive overview of data harmonization and stroke. Actually, we have a couple of questions in the chat. The first one comes from Giorgio Colangio. In case of big data sets, combination of all values and variables can be very complex. So Gene AI emerged as a valuable resource these last years. So do you think it's something that can be included in harmonization processes?
For sure, these methods that reduce your variable space and give you kind of pointers on which variables to focus on, and the variables that have potential, let's say, predictive power in a certain context is very welcome. But this needs to be done in the prep phase of data harmonization. So these tools can be used for preparatory work for data harmonization. But then when you decide on which variables you will use, then you need to go through this classical protocol of establishing the mappings between the variables, constructing the common data model. So it can make your job easier in the first phases by telling you on which variables it's worth focusing. So yeah.
Excellent. So the second question is there any metrics to evaluate the harmonization level of the data? Good one, huh?
Yeah, it's a good one, yeah. I would need to check, not very sure, because yeah, it is a tricky thing. It is very subjective. So getting an objective measurement of harmonization when you don't have the ground truth previously defined, it's tricky. So if there would be a standard, and then all the hospitals map to that one standard, then it would be easier. But if there is no standard, it's tricky. One could assess the level of harmonization, I think, a posteriori after building the models. So yeah, that might be one way of doing it, but not really sure.
Okay.
Maybe Draghi can jump in, but this was just kind of my my view.
Yeah,
Okay.
I concur. The data harmonization is fairly subjective and it's dependent on the situation at hand. It depends what kind of actors you have, what kind of repositories you're trying to merge, to harmonize. And it's typically these kind of things would be evaluated through compliance checklists. So you will have best practices somehow compiled together, and at the end you assess the whole process, how much it complied to that good practices checklist. Assigning a number, like in terms of assessing the predictive performance of AI models, it would be fairly difficult. But assigning a degree of compliance could be attainable in this case. You can say we are compliant with 95% of the guidelines for best practices, which are these, and you can state what was non-compliant and why.
Okay, it's 10 past 2, so we need to stop here. So once again, thank you very much for this excellent presentation. It's definitely a hot topic and difficult to understand. You made it so clear for everyone. So for sure, there are more questions that in the next meetings we will solve more of them. So I would like to invite all of you to the next chapter, the next episode of this set of webinars, and the Trustworthy Consortium is going to be next year, January. So thank you very much all for your attendance, for your questions, for your interest. Keep going, get in touch. So bye.
Thank you.
Bye.
Bye-bye.
Thank you. Bye.